Good afternoon, sir.
Good afternoon. Good afternoon. So now, yesterday we discussed about the introduction to engineering material. Once again, we'll discuss about the introduction and types of polymerization. Okay. So the model 3 is engineering material. In the engineering material, the main topics are polymers, classification of polymerization. Classification of polymerization are three types that are addition polymerization, condensation polymerization, and copolymerization. Screen is sharing now?
Yes, sir.
Okay, right. Now, what is on the screen now?
Polymers classification with examples and
Okay, plastics.
plastics, thermoplastics.
Okay, right. Thank you. Likita?
Yes, sir.
Okay. Mute yourself. So now next one, in the module 3, the engineering materials, the main topics are polymers, classification of polymerization, that is addition polymerization, condensation polymerization, copolymerization. Next one is plastics. What is the plastics? What are the uses and applications of plastics and how they are classified? So plastics are classified in two types, that are thermoplastics and thermosetting. Next one is the compounding of plastics. Compounding of plastics means we are adding the additives to in the molding process. We are adding some additives. Then the plastic show their properties. Next one, very important question, that is preparation, properties and applications of polyvinyl chloride, Teflon, bakelite, and nylon 66. Next is the elastomers. In the elastomers, the main topic is natural rubber. So how we are getting the natural rubber? What is the process involving in the natural rubber? And vulcanization. What is vulcanization? And what is the applications of vulcanization? Next one is the synthetic rubbers. So that synthetic rubbers means man-made rubbers, that are preparation, properties and applications of vinous rubber and thiol rubber. Next one is the biodegradable polymers. In the CAE 1, we have only four topics are there. One is polymerization, classification of polymerization, plastics, compounding of plastics, preparation, properties, applications of polyvinyl chloride, Teflon, bakelite, nylon 66, and next one is the biodegradable polymer. Only we have 5 topics are there. Today we will finish the first topic, that is classification of polymerization. Next one is the lubricants. So in the lubricants, introduction to the lubricants, that means the characteristics of lubricants and the mechanism of lubricants, that is thick film lubrication, thin film lubrication, and extreme pressure lubrication. Last one is the properties of lubricants, that is the flash point and fire point, cloud and pour point, viscosity and oiliness of lubricants. So these all are the module 3 topics. Today we'll discuss about the classification of polymers. Before that, we'll discuss about what is the polymer. So polymer means Polymer means the monomers combined to form a large molecular gain molecule, that is called as polymer. Monomers combined to form a large molecular gain molecule, that is called as polymer. For example, if you are taking the H2C11CH2, that is ethylene molecule, undergo polymerization, that form as a H2C, CH2 taken n times. So in this, you see, this is n number of ethylene molecule undergo polymerization, that form as a polythene, that is polythene. So polymer means the single monomers combined to form a large molecular gain molecule, that is called as polymer. The best example of polymer is polythene, polyvinyl chloride, polyacrylonitrile, polystyrene, bakelite, nylon 66, Teflon, etc. Now, next one is a polymerization. Now, what is meant by polymerization and how they are classified? Addition, the classification of polymerizations are addition polymerization, condensation polymerization, and copolymerization. Yesterday already we discussed about introduction to the polymers. They possess the polymers possess the good mechanical strength. Most of the polymers are non-toxic and safe to use. They are low densities and transport easy. They possess a good mechanical strength and resistance to sunlight, moisture, acid, alkali, and resistance to corrosion. There is will not absorb moisture when exposed to the atmosphere. These all are the common properties about the polymers. The properties of polymers are common properties are resistance to sunlight, moisture, acid, alkali, and resistance to corrosion and insulating purpose. We are using the polymers. So this can be function as a good thermal and electrical insulation. These can be molded and fabricated easily. The plastics are easily fabricated and molded. So they possess aesthetic colors. So the polymers are showing aesthetic colors. Is it right or wrong? Different colors: red, blue, white, etc. Transparent colors are black color, etc. So that that will show the aesthetic colors. This is a polymer example already just now discussed. Now. So polymer ethylene. So this is the ethylene molecule. Ethylene molecule undergo polymerization that form as a polyethylene. Polyethylene. So in this, so which are this repeated units of polymer is called as monomer. Which is called as monomer? The ethylene molecule is there. Na? The monomer repeating units that monomer is CH2. CH2. Yes, is right or wrong? So this is called as monomer. Now the degree of polymerization means how many number of monomers are involving in the polymerization process. That is called as degree of polymerization. Suppose 100 number of ethylene molecules are present. So degree of polymerization is 100. If 1000 number of ethylene molecules are involving in the reaction, so that degree of polymerization is 1000. So homomer means polyethylene. So same molecules undergo polymerization that form as a homopolymer. Copolymer means different monomers. So this homopolymer means M. N number of M that form as a M taken N times. So this is called as homopolymer. Homo means same molecule repeating. Same molecule is repeated. So best example is polyethylene. Polyethylene. Copolymer. Copolymer means this is a Buna S rubber. Buna S rubber is the copolymer. That means X and Y. X and X plus Y combined to form a XY, X number, N number of polymer formation takes place. So in the copolymer, the monomers are different type of monomers combined to form a large molecule or gain molecule that is called as copolymer. Buna rubber. Now, what is meant by polymerization? So polymerization means it is a chemical reaction. It is a chemical reaction in which monomers are combined to form a large molecule or gain molecule with or without elimination of small molecule takes place. That are called as polymerization. Suppose, for example, you see without elimination of molecules, I will take the example of that one. Suppose, for example, if you are taking the same molecule, that is H2C double bond CH2, ethylene molecule. When undergo polymerization that form as a H2C CH2 taken N times. So here there is no elimination of N number of ethylene molecule. There is no elimination of small molecules. Some of the polymers like nylon 66. So in the nylon 66, the monomer of that one is H2N CH2 taken 6 times hexamethylene diamine NH2 plus adipic acid plus CH2 4 and C double bond OH. So this is the hexamethylene diamine, hexamethylene diamine, and this one is adipic acid. So this will undergo polymerization. Removing of water molecule takes place. That we are getting the nylon 66. So this is here what water polymerization means. It is the process in which it is a process or It is a chemical reaction in which single monomers are combined to form a large molecular gain molecule with or without elimination. So without elimination is a polythene, with elimination is nylon 6,6. So this process is called as polymerization. So classification of polymerization is mainly the classification of polymerization is three types of polymerizations are there. So types of polymerization, there are the three types of polymerizations are there. There, number one is the addition polymerization, number two is the condensation polymerization, number three is the copolymerization. So here, so number one, is the addition polymerization, number two, condensation polymerization, number three, copolymerization. Now, let us discuss one by one. What is the addition polymerization? What is the condensation polymerization? What is the copolymerization? Addition polymerization. What is meant by addition polymerization? Addition polymerization means exact multiple of virgin molecule is called as addition polymerization. Addition polymerization means exact multiple of virgin molecule is called as addition polymerization. In the exact multiple means addition polymerization, this is also called as chain growth polymerization. So in the chain growth polymerization or addition polymerization, both are same. So what is addition polymerization? Addition polymerization means exact multiple of virgin molecule is called as addition polymerization. The single monomers combine to form a large molecular gain molecule, that is also called as addition polymerization. In the addition polymerization, you see the double bonds are converting into single bonds. How the double bonds are converting into single bonds? Let us discuss one by one. So first example is, you see here, all of you listen carefully. This is a very, very important one. Addition polymerization means exact multiple of virgin molecule is called as addition polymerization. In the addition polymerization, double bonds are converting into single bonds. There is no elimination of any small molecules. So that are H2C double bond CH2, that will undergo n number of ethylene molecule. This is called as ethylene undergo polymerization in presence of temperature, pressure and catalyst, that form as a H2C CH2 taken n times. This is called as polythene. Number one, here you see exact multiple of virgin molecule. You see all are the multiple of virgin molecule. What is the virgin molecule? Ethylene. But here double bonds are converting into single bonds. There is no elimination of small molecule takes place. So first one is the ethylene molecule. Second one is the vinyl chloride. H2C double bond CH Cl. Vinyl chloride undergo polymerization, that form as a H2C CH Cl taken n times. This is called as PVC. 588 over 588. Rule number 588. 588. మీకు ఇచ్చిన సార్ నేను అది లిస్ట్ 588 ఎవరమ్మా 588 588 వినపడట్లేదమ్మా 588 578 578 వెంకటరెడ్డి గారు So now students listen, addition polymerization. First one is the ethylene, and next one is the vinyl chloride. Third one is the acrylonitrile, H2C double bond CHCN. So this is called as acrylonitrile. So CH2 double bond CH2 is called ethylene, and CH2 double bond CHCl is the vinyl chloride. This one is the acrylonitrile. This acrylonitrile undergo polymerization in presence of temperature, pressure, and catalyst that form as a H2C CHCN taken in time. So this is called as polyacrylonitrile. Now fourth one, that is H2C double bond CH. So this is a benzene ring. So this is called as styrene. Styrene undergo polymerization that form as a polystyrene H2C CH taken in time. So this is called as polystyrene. One more example is propylene H2C double bond CH CH3 propylene CH3 double bond CH3 is the propylene. Propylene undergo polymerization that form as a polypropylene H2C CH taken n times and CH3. So this is the polypropylene. So these all are the example for addition polymerization. So addition polymerization means exact multiple of original molecule is called as addition polymerization. So in the addition polymerization, the double bonds are converting into single bonds. The monomers are repeating links of repeated units of monomers are formed. There is no elimination of any small molecule takes place. When the monomers are undergo polymerization, the molecular mass of the polymer is slightly increases. So this is about addition polymerization. I will show the example again. Slide. So addition polymers are formed adding the monomers without any loss of atoms or forms. So this is the ethylene molecule. You see, ethylene molecule form as a polythene, and one more is vinyl chloride CH2 double bond CHCl that form as a polyvinyl chloride. One more example is polystyrene, polyacrylonitrile, etc. This is about addition polymerization. Now next one is about condensation polymerization. Now condensation polymerization means the monomers combine to form a large molecular gain molecule with elimination of small molecule takes place. That is called as condensation polymerization. Condensation polymerization means the monomers having the partially positive and negative charge with elimination of small molecule takes place. Then we are getting the polymer. So the polymers are condensing polymer. When condensation polymerization goes on, thermositting resins are formation takes place. Thermositting resins. What do you mean thermositting? So plastics are two types: thermoplastics and thermositting. Thermoplastics, when we are giving the temperature, easily soften. When we are cooling, harden. Okay, thermoplastics. Suppose you see, all of you see the bottle. So this bottle is a thermoplastic only. Thermoplastic. When we are giving the temperature to this bottle, easily melting takes place. That means easily flexible. Okay. After cooling, harden. Thermositting means suppose you see the pressure cooker handles are there. Pressure cooker handles are switchboards, switches. That all are the thermositting resins. When three-dimensional crosslinks or formation takes place, in the molding process become hard only. That can't be undergo any deformation or any softening. So like that, plastics are called as thermositting resins. Thermoplastics are when heating, soft, cooling, harden. But thermosittings are under the molding process that become hard only. That does not form as a soften. So the best examples are pressure cooker handles, switches, etc. Now, best example for condensation polymerization is nylon 6. So this nylon 6, listen students, the preparations are very, very important in the examination. You have must be write the example. So in this condensation polymerization, first one, the example for condensation polymerization is nylon 6. So the monomer of nylon 6 is caprolactam, CH2, 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 NH, C double bond O. So this is called as caprolactam. Capro. So in the caprolactam, ring cleavage takes place in between the amide bond. So NHC double bond O bond is NHC double bond O is called as amide bond. So this amide bond cleavage takes place, easily cleavage takes place, then form as a nylon 6. How? HN CH2 taken 5 times, C double bond O. So this is the nylon 6. Nylon 6. Nylon 6. So why we are called a nylon 6? Why? Because here how many carbons are present? 5 plus 1. 6 carbons are present. So simply we are denoted as nylon 6. So this is about preparation of nylon 6. So condensation polymerization means the monomers combine to form a large molecule or gain molecule with elimination of small molecule takes place. With elimination of small molecule takes place in the condensation polymerization. The monomers having the partially positive charge and partially negative charge. Then partially positive and negative charge are present. Then easily removing of small molecule takes place. Now one more example is nylon 6,6. One more example is nylon 6,6. So in the nylon 6,6, the monomers of nylon 6,6 is hexamethylene diamine. H2N CH2 taken 6 times NH2 plus this one is hexamethylene diamine is reaction with adipic acid HOC double bond O CH2 taken 4 times C double bond O OH. So this is called as adipic acid. So in this, what happened? NH lone pair of electrons are present here. So oxygen. So when reaction is going on, removal of a small molecule takes place, H2O takes place, removal of H2O molecule takes place, then we are getting the nylon 6,6. So the structure of nylon 6,6 is NH CH2 6 times NHC double bond O CH2 taken 4 times C double bond O taken n times. So this is called as nylon 6,6. How? Why we are called as nylon 6,6? Why? Because here how many carbons are there? 6 carbons are there. Here how many carbons are there? 1, 4, 1. That is 6 carbons. So simply we are called as 6. This is called as nylon 6,6. 2 6 here in the hexamethyl 6 carbons are there. Adipic acid also 6 carbons are there. When undergo condensation polymerization, that gets the nylon 6,6. This is the example for condensation polymerization. One more example also is there. That is urea formaldehyde. Next one is urea formaldehyde. So in this urea formaldehyde, the monomers of urea formaldehyde is urea. What is the structure of urea? NH2, C double bond O, NH2. So this urea is the first organic compound in all over the world. The scientist Euler, he discovered the urea. This is the first organic compound. When this urea is reaction with formaldehyde HCHO, that form as a urea formaldehyde. How the urea formaldehyde formation takes place? HN, C double bond O, HN, CH2, NH, H2, C double bond O, NH. So this is the structure of urea formaldehyde. Urea formaldehyde. This is another example for condensation polymerization. So condensation polymerization, one is the nylon 6, nylon 6, nylon 6,6, and one more is urea formaldehyde. One more is becquerelate. Becquerelate. So this becquerelate is here. The monomers of becquerelate is phenol. Then phenol is OH. Is reaction with formaldehyde with CHO. So that form as a monomethyl phenol. If 3 number of formaldehyde formation takes place, that produce the trimethyl phenol. Trimethyl phenol formation takes place. How? So OH, CH2OH, ortho, CH2, sorry, CH2OH, and here also CH2OH. So this is called as trimethyl phenol. Trimethyl phenol. This will undergo polymerization that form as a becquerelate. This will undergo polymerization that will getting the becquerelate. So these all are the example for condensation polymerization. So condensation polymerization means the monomers contains a partially positive and negative charge. So in this polymerization, the removal of small molecule takes place. Without removal of small molecule also, condensed products or formation takes place. That example is nylon 6. And urea formaldehyde, the water molecular elimination takes place. In the becquerelate also. Okay. So these 4 are the best example. For one more is PET. You know, all of them know the PET, polyethylene terephthalate. PET bottles, all of you know that PET bottle, no? So that why we are called as a PET bottle, that are made up by polyethylene terephthalates. So in the polyethylene terephthalates, the monomers of polyethylene terephthalates are terephthalic acid and ethylene glycol. Ethylene glycols are present. Monomers, terephthalic acid and ethylene glycol undergo polymerization. We are getting the polyethylene terephthalate, PET. Simply we are called as PET. Why we are called as PET? Polyethylene terephthalate. These are used for storage. Cool drinks bottles are there, thumbs up, Coke or Mirinda, Mazda, etc. That purpose we are using PET bottles. That we can't reuse the bottles. Okay. So this is about condensation polymerization. Now, so nylon 6, condensation polymerization, nylon 6,6, preparation. Once you observe the preparation, so this is hexamethyl diamine, adipic acid, under the polymerization, we are getting the nylon 6,6. So these nylon 6,6 applications are nylon fabric. You see, nowadays completely we are depends upon plastic material only. Each and every family or any companies or any institutions, nylon fabrics, nylon plastics, and nylon rolls. These are by using the nylon 66, we prepare the nylon fabrics, nylon plastics, and nylon rolls. Next one is the copolymerization. Addition and condensation is completed. Now, next one is the copolymerization. Copolymerization means different monomers, X number of monomer and Y number of monomer combined to form a large molecule or gain molecule. That is called as copolymerization. So, in the copolymerization, X number of monomer. X number of monomer means, suppose example for copolymer is Buna S rubber. Buna, first synthetic rubber, that is Buna S rubber. The monomer of Buna S rubber is 1,3 butadiene H2C double one CH CH double one CH2. So this is 1,3 butadiene. Then 1,3 butadiene is reaction with styrene. Form as a Venus rubber. How? This is the X number and this is the Y number. Now that we are getting H2C CH double one CH CH2 taken X times H2C CH taken Y times. So this is called as Buna S rubber. What is copolymer? Copolymer means different monomers. X and Y number of monomers combined to form a large molecular gain molecule without elimination of any small molecules. We are getting the polymer. The first synthetic rubber is Buna S rubber. In the time of Second World War, scarcity of rubber takes place. At that time, our scientists discovered the rubbers. That rubbers are called as synthetic rubbers, that is man-made rubbers. Now, one more example for copolymerization is many number of examples are there. One more is H2C double bond CH2, that is ethylene. Ethylene is reaction with vinyl acetate, that is H2C double bond CH Cl. This is the ethylene. This is vinyl chloride. Undergo copolymerization. Undergo X number of ethylene molecule, X number of ethylene molecule, and Y number of vinyl chloride. Undergo copolymerization that form as a H2C CH2 taken X times H2C CH Cl taken 5 times. So this is the polyethylene. Name of this one is polyethylene co-vinyl chloride polymer. Okay, na? So polyethylene. So this is ethylene molecule. Ethylene molecule that form as a polyethylene co. Why? Because this is a copolymerization. This will undergo copolymerization. Co-vinyl chloride. Simple. I'm writing the names only. Poly and co I'm adding. So polyethylene co-vinyl chloride. What is the name of this one? Poly 1,3 butadiene co-styrene polymer. Simply the name of general name of that one is Buna S rubber. And one more example, you take H2C double one CH CN plus styrene. H2C double one CH. So this one undergo polymerization. Copolymerization that form as a polyacrylonitrile co-styrene polymer. Co-styrene polymer. This is about the copolymerization. Addition polymerization, condensation polymerization, and copolymerization. Once again, listen, students. Addition polymerization is exact multiple version molecule is called as addition polymerization. In the addition polymerization, single bonds are double bonds are converting into single bonds only. There is no elimination of small molecule takes place. The monomers are repeating takes place. Examples are polyethylene, polyvinyl chloride, polystyrene, polyacrylonitrile, or polypropylene, etc. Condensation polymerization means the monomers having the partially positive and negative charge. Losing of small molecule takes place like water, NaCl, or CH2OH, or NH3, etc. takes place. Then we are getting the condensed products or condensed polymers that are nylon 6, nylon 6,6, urea formaldehyde, bakelite, polyethylene, terephthalate. Next, one more classification of polymerization is copolymerization. Copolymerization means different number of monomers, X number and Y number monomers combined to form a large molecule or gain molecule. That is bunized rubber. N number of, you have to give the N number of examples. 1,3 butadiene, styrene, ethylene, styrene, ethylene, acrylonitrile, ethylene, XYZ. Okay. So this is about types of polymer, classification of polymerization.
Okay.
So next one, very important one, that is a difference between difference between condensation polymerization and addition polymerization. So all of them know addition polymerization means the monomers containing the double bonds are converting into single bonds. But the monomers contain the partially positive and negative charge. So in the condensation polymerization, also called as step growth polymerization, addition polymerization also called as chain growth polymerization. Why? Because addition polymerization, the chain, why we are called a chain? It contains a long chain only, there is no branches. But in condensation polymerization, it contains a step growth. Steps are formed. So that's why we are called as step growth polymerization. In the condensation polymerization, it takes place monomers having reactive functional groups. So that means it having the monomers having positive and negative charge. That simply are called reactive functional groups. So addition polymerization, it takes place only in monomers having the multiple bonds. Multiple bonds, nothing but double bonds or triple bonds. Next one is in the condensation polymerization, it takes place with elimination of simple molecules like water, HCl, OH, etc. There is no elimination of small molecules in addition polymerization. Repeat units of monomers are different. The repeat units of monomers are different. Suppose nylon 6,6 is there. The monomer is hexamethyl and adipic acid. The both monomers are different. So that's in the polymers form. Repeat units of monomers are different. But in the addition polymerization, monomers are same. Ethylene same. Polymer is formed in gradual steps. The reaction is fast. The polymer is formed once only. So here in the condensation polymerization, the polymers is formed gradual steps only. Step by step we prepare. But in addition polymerization, single time. Once the reactant is ethylene is converted into simply converted into ethylene. In the condensation polymerization, the molecular mass of polymers increase through the reaction. In the addition polymerization, this is very little change in the molecular mass through the reaction. Product obtained maybe thermosetting and thermo. In the condensation polymerization, the product obtained maybe thermosetting or thermoplastics. But addition polymerization only thermoplastics are found. What is thermoplastics? Thermoplastics means easy to when the polymer molecule when we are giving the temperature or heating easily soften. After cooling, harden. But thermosetting are there, not like that. In the molding process, once that become hard, we can't soften. So like that materials are called thermosettings. So this is about the difference between the condensation polymerization and addition polymerization. Okay. Difference types very important. Any one question they will ask in the examination point. Differences are a classification of polymerization. Right? Any doubts? Anyone? Please raise your hand. Any doubts? Otherwise, chat box. Chat box. You have any doubts? Please ping it. Naveen.
Sir.
Naveen,
Hello.
okay?
Yes, sir.
Any doubts?
No, sir.
What you can do once I send the PPT to you, okay? Once you see the PPT. This PPT is there, na?
Yeah.
I'll send you.
Okay, sir.
PDF file. Once you see the reactions are very all of you, not only Naveen or anyone. Kaushik?
Yes, sir.
Kaushik. Clear? Any doubt?
No, sir.
Okay. 69 రాలేదు. 89
నేను నాకు తెలిసి
Sir?
ఆమెకి ఎవరో చెప్తున్నారు
No, huh?
చెప్పకండి
yes,
వేరే వాళ్ళకి అంటున్నారు. మీరు
Okay.
ఇంటర్ కూర్చొని
Any doubts
మాట్లాడుకోండి.
now?
No, sir.
Okay. Right? Okay. Thank you.
Okay.
అదే ఎందుకు మీరేమన్నా ప్రాబ్లం ఉంటే మీ ఇద్దరు మాట్లాడుకోండి వేరే వాళ్ళు